backwards? Like, don't I have to go that way?
Nope, it's as if, and let me move this.
Never mind.
As if you were reading it.
I didn't do it on a separate piece of paper. Don't kill me. I know. Oh, it's a little crooked. Oh, it's a lot of crooked.
You can just like zoom in on yours.
Oh, that's outwards. Oh. Okay, good enough.
Ooh, there. That looks beautiful.
Okay, so the original problem was 3/2 times z plus 3 minus 1/4 times z plus 24 equals 0. So then you find the least common denominator, which is 4. So then you get 12 over 2, which simplifies to 6, times z plus 3, and then 4 over 4, which simplifies to 1. So then you get minus 1 times z plus 24. Then you distribute the 6, so you get 6z plus 18. And then you distribute the negative 1, so then you get negative z minus 24. And then you combine all the like terms and get 5z minus 6 equals 0. And then you take the 6 over and get, and then divide by 5 and then get z equals 6 minus, or 6 divided by 5. It's so weird doing it without Nina. Nina was always my partner. Michael, looks like we're partners now.
Any questions for Chelsea?
Oh, I kind of just already got up.
Yeah, I'm like, forget you. Nobody's allowed to ask questions. All right, so Miss Asia has number 9.
See, I was gonna do that, but I forgot. Okay. And this is longer than mine.
Yeah,
So,
a little bit.
Okay, so it was 7 over 2x plus 1 minus 8x over 2x minus 1 equals negative 4. So first you get rid of the denominator by multiplying both sides by 2x plus 1 and 2x minus 1 because it's the bottoms. And then you like multiply that through and or distribute them. And then you combine the like terms to get negative 16x squared plus 6x minus 7 equals negative 16x squared plus 4. And then you just like add and subtract both sides to get 6x equals 11. And then you get x equals 11 over 6. That makes sense.
Anyone have questions for Asia? I'll actually take that. If that's all right. Keep it as a souvenir. Maybe you should sign it so that when you're famous, I have your souvenir, your signature. This is your famous signature right here? Yeah? So, as I said, I'm going to talk about 14 and 17. 14 was dealing with a radical. Asked you to find x and y intercepts. So it gave you x times the square root of x plus 2. And again, the directions were to find the x intercepts algebraically and then graphically, and also the y intercepts algebraically and graphically. So kind of doing two pieces. So if you're finding the y-intercept, I said Friday, that's the easy one to find when it's already in y equals form, which this is. So a y-intercept, you take the x, make it 0. Both x's in this case, you make them 0. And Virginia, if you have 0 times the square root of 0 plus 2, your answer is just 0. So the intercept would be 0, 0. The x-intercept is a little trickier because usually you got to solve for x. Now the equation is in y equals form. Brandon, I'm getting you a pass before I forget.
Thank you.
So if we set this equal to 0 because the x-intercept is when the y is 0, we end up with x and then the square root of x plus 2. How do you solve for x? Right?
You divide by x on both sides.
No!
If you divide by a variable, then that variable vanishes and it's not like there anymore.
You got the right answer by doing it.
Blah. Then you don't have that x-intercept though. It's like poof, gone. It's missing an x-intercept. And there's 2 and now you have 1.
Well, then you get rid of the x on both sides and then you square 0, you still get 0.
Yeah, but dx. Anyone else know what to do? Yes.
You square it.
So she said you square it. Before you square it, we're going to do something. If you factored a problem and you got the answer of x plus 3 and x minus 2, so you did the factoring, you set it equal to 0, how do you solve for x? How do you find x after you factor it, Chelsea?
You set x equal to 0.
You set x equal to 0, so you take this, x plus 3, put it equal to 0. You take this one, x minus 2 equals 0. Chelsea, do you know what that property was called?
Isn't it the zero product property?
It is the zero product property, which means when a problem is set equal to 0 and you have the product of x's, you're allowed to split them up and solve for each of them individually, which is what we have right here. Even though there's not parentheses, it's still a product because you have x times the stuff underneath the radical. So you're taking the x that's in front and setting it equal to 0. Well, right there is my x-intercept, which I know it's also the y-intercept, but that's how you would find that x-intercept, by taking the x in front, setting it equal to 0. And then you take the radical part, the square root of x plus 2, set it equal to 0. Eris, this is when you would say, all right, so let's get rid of that square root by squaring both sides. We end up with x plus 2 is still equal to 0, and then x is equal to negative 2. So zero product property is when you're multiplying quantities together, and it must all be multiplication, which this is. So I have x times another quantity underneath the radical. You can split them apart and solve for each of them individually. That's how you would solve for each of those x's. Questions? All right, so then number 17 was like the last problem we did on Friday, which said to find the intersection points algebraically and graphically. And this one gave us 2 equations. The first one 2x squared, the second one 2x to the 4th minus 2x squared. So if you did this graphically, you probably want to plug it in your calculator. Same thing with that other one. Like, this is not considered a basic graph. If it was just the square root of x plus 2, yes. But with that x in front, it's no longer a basic quick graph. So put them in the calculator. If you're not sure if it's a basic graph or not, use the calculator to help. So when you would graph this, just talking about the first one, Libby, if it's 2x squared, what's the shape of that?
That would be a parabola.
Yeah, that one's the parabola. So 2x squared looks something like that. Did anyone else put the 2x to the 4th minus 2x squared in, like the shape that you got with that second equation, Virginia? Yeah, it's a W. Something like that. Maybe not exact. I'm trying to go from memory here. My binder isn't open to look to make sure I'm right. I think I'm mostly right. So our goal is to find where they intersect. Well, they intersect on the left side, on the right side, and in the middle. They intersect at 3 places. So that means algebraically I need to find those 3 places that they are intersecting. On Friday we talked about doing that using substitution and elimination. Which one would be easier when it's in this form? Substitution or elimination? Kate, what do you think?
Substitution.
Yeah, substitution. Because they're both y equals, which means you can take 1 plug it in for the other y, so 2x squared equals 2x to the fourth minus 2x squared. And instead of taking the 2x squared to the left and then dividing, we don't want to divide by a variable, we are going to set it equal to 0 to,
Wait, is that at 1x to the 4?
is it 1x to the fourth? This right here? Thanks. Thank you, Chelsea. So, Chelsea, if we set this equal to 0, what would the goal be if you set something equal to 0?
Like, to solve.
To solve for it, so set it equal to 0. This becomes minus 4x squared. How would you solve for that then?
Oh, well, it's a perfect square by so it would be x squared minus 2x. And then,
You make it harder than it is.
am I?
What do they have in common?
X squared.
An x squared. So if you take out an x squared, what goes inside?
X squared and then minus 4.
Right. And then that's the perfect square binomial. That would factor as x plus 2 and x minus 2. So I didn't divide. If you divide, you lose the power of x. It's gone. You're taking away an x-intercept from the problem. You're really changing the graph if you divide by a variable. You've taken the graph and totally changed its shape. So instead, you're keeping the variable in and then kind of like separating each one of them. So here x is negative 2. Over here x is positive 2. And then this, if you set it equal to 0, technically it's x squared is equal to 0, which really means x is equal to 0. That's how you get that third intercept, by factoring it out and keeping it in the problem. So if you're finding where they intersect, these are 3 x's. How many y's should you have? 3, one for each of them. So going back to the original problem, it was y equals 2x squared. So if you plug a 0 in, 2 times 0 squared is 0. If you plug a 2 in, 2 times 2 squared is 8. And if you plug a negative 2 in, 2 times negative 2 squared is also 8. So algebraically, that's how they're, like those 3 x values were kind of arrived at by using the factoring, setting them equal to each other, and then solving. Questions? So we're going to do a little bit of solving equations today. Before you put that homework assignment away, if you just flip the page in the packet, your homework tonight is just 1 through 5. And you'll either have to use the quadratic formula or completing the square for number 1, whichever you prefer. So number 1 is not factorable. You'll have to use the quadratic formula or completing the square. Tomorrow we'll go through the examples that are similar to the ones on the bottom of the page. We're just going to kind of touch on those first 5 today. Questions? So then in the notes packet portion, it should say day 2, solving equations algebraically and graphically. So this was supposed to be a warm-up. We're just going to go through it together as a class. It says to solve and check. And we have the absolute value of 10 minus x, or I'm sorry, x minus 10. That's equal to x squared minus 10x. On Friday, we talked a little bit about how to work through absolute value. Does anybody have an idea of what we do to solve this? Chelsea?
Don't you set x minus 10 equal to x squared minus 10x, and then x minus 10 equal to negative x squared plus 10x?
Nice, yeah. So to get rid of the absolute value, whatever's on the right side, you're supposed to keep the same, and then you're supposed to make negative. Well, if it's a quantity, you need to make the whole thing negative. So we're taking that x squared minus 10x, making all of that negative. So she said negative x squared, and then that becomes plus 10x. So absolute value, there's a left and a right side because it's a v. There's a left and a right side of a 0 as well. That's same distance from 0 on the left and the right. That's how we create those two equations. So if there's an x squared and an x in the problem, that's when you're going to have to factor it. I like to factor with x squared being positive. So the one on the left, I would take the x and the negative 10 and move it to the right side where I have a positive x squared. So keeping x squared stationary because it's positive, I would subtract x to give us negative 11x and add 10. Again, I like having x squared being positive. And then factoring that, Michael, do you know how x squared minus 10x, or minus 11x plus 10 factors?
Yeah, it'd be like x squared minus 10x minus 1x, and then you break that down.
And then he said break that down. So the first one you would pull out the x, the second one we would pull out a negative 1, and then we would be left with x minus 1 and x minus 10. So two answers here, a 1 and a 10. So that's the one side that Chelsea told us. Libby, the other side, if we set this one equal to 0, I would take the x to the left so that it becomes a positive x squared. If we do that, Libby, we would be looking at x squared.
X squared minus 9x minus 2. Or, wait, minus 10, sorry. I
That's
wrote
okay.
that wrong.
And then when you factor that and break it down, what do you get?
It would be,
No, you still have the 2.
yeah, x minus 10, x plus 2. Or x1.
You like 2 today,
Apparently.
apparently. So we get an x equals 10 and an x equals negative 1. So I have 3 answers up here. But an absolute value graph is a V, and it only has a left side and a right side. So 2 of them are correct. Which one would be obviously correct? Chelsea?
The 10.
A 10, because I mean you get the answer in both of them. You can just do a quick mental check. 10 minus 10 is 0. Absolute value of 0 is 0. 10 squared is 100 minus 10 times 10 is 100. You get 0. So this one is good. I mean, you get the same answer in both of them. So that's kind of like a little hint. That's going to be one of the answers. However, positive 1 and negative 1, only one of them is the solution. And we need to check to make sure that it works. So taking that 1 and plugging it into the original problem, not the ones you created, back to what you started with. That's how you find an extraneous solution. So we would have the absolute value of 1 minus 10. That's equal to 1 squared minus 10 times what? The original problem is where that goes. You're checking to make sure it works. So Eris, 1 minus 10 is?
9.
And on the other square side, 1 minus 10 times 1 is? Negative 9. Does the absolute value of negative 9 equal negative 9? No, because 9 does not equal negative 9. So Eris, what does that mean about 1? It's not an answer. That one's extraneous. Doesn't work. I'm going to check the other one just to make sure it works. So I would have negative 1 minus 10. Negative 1 squared minus 10 times negative 1. Just to make sure this is okay. So negative 1 minus 10 is negative 11. Over here, negative 1 squared is 1. Negative 10 times negative 1 is 10. So that makes 11. Eris, does the absolute value of negative 11 equal positive 11? Yes, it does, because absolute value makes it positive. So the answers would be 10 and negative. Any questions? So if you go underneath, number 1 says to solve the equation by undoing. It's kind of in parentheses because it's not really a pure mathematical word, so we'll just say it kind of as a process that we use. think undoing means, Alice? What would you do to?
Well, I would square root the 36.
Yeah. Square root the 36, square root the other side. You want to get rid of the square. So to undo it, you take the square root. You kind of do the opposite. Alice, when you take the square root of 36, what do you get?
6.
Oh, you're
A
so.
little plus or minus.
There you go. Good. You get a plus or minus 6. Because you had something that was squared, when you put the square root in the problem, you end up with a plus or minus answer. So Alice, your two solutions are
2 and -10.
and -10. Nice job. Again, two answers there because something squared is a parabola. We still have that left and right side, so we have one on each side of the parabola. Any questions with that one? You don't need to FOIL. Because if you FOILed it, you'd have to set it equal to 0, and then you'd have to factor it to like 6 steps instead of just 1. So get rid of the square by taking the square root. Number 2, underneath, this one says solve the equation by factoring. Good little warm-up to have right before you have a factoring problem. How do you factor this? It says x to the 4th minus 5x squared plus 6. So it's a trinomial. Got the AC going on here. There's just a 1 in front of that x to the 4th, so you don't have to use the entire AC method if you don't want to. Grace, do you know how it would factor?
would be x to the 4th minus 2x squared minus 3x squared plus 6.
Awesome. So because it's a 6 and a -5, we have -2x squared, -3x squared. That's how you account for the x squared part. And then Grace, what would we take out of the front pair?
X squared.
And then the second pair? So pulling them together, we have x squared minus 3 and x squared minus 2. And that's equal to 0. So now it's factored. What do you do to solve? Chelsea?
Set each of them equal to 0.
Yeah, set each of them equal to 0, which really means x squared is equal to 3, x squared is equal to -2, or how about positive 2, not -2. And then just like we did with the other one, if you have an x squared, to get rid of the squared part, take the square root of both sides. The square root of 3 is not a whole number. We don't want a decimal, just keep it as the square root of 3. But because you took the square root and applied it to the problem, it's a plus or a minus. Same thing with the square root of 2. It's 1.41, blah, 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 blah. I don't want a decimal, just keep it exact. So plus or minus square root of 2. Questions? So we're going to hold off on the last one, the quadratic formula. We'll get to it tomorrow, but I think some of you might remember that quadratic formula. As I said, the first problem of your homework you'll have to use it for. So if you want to jot it down just to have something to jive your memory. You can also use completing the square for number 1. It doesn't have to be the quadratic formula.